1. This is the first unit on surface area and volume. This is lesson 1. It's an introduction to solids. Let's look at some man-made solids. This is New York City. Many of the buildings are made up of cuboids. This is in France. This is a glass pyramid and the base is square. This building is a 12th century defensive tower in Germany. You can see the main structure of the building is a cylinder, and at the top of the building is a cone roof. Look at these houses. These are hexagonal prisms all joined together. Here's a paper cup and the shape is a cone. You probably see these when you go to the dentist or a doctor. This is a bucket. It's called a frustrum. Notice how this looks like a cone. The bottom has been cut off and the top has been cut off. So that is actually part of a cone. These are spheres. They're held inside a wheel bearing. These are very common in vehicles like cars and trucks and bikes. These are examples of solids found in nature. This is a cone snail. It's found in the deep sea reefs. They're quite dangerous. This is a mineral fluorite. It's a crystal. Its shape is an octahedron. This is an adenovirus, and the shape is an icosahedron. We'll look at that more soon. This is the methane molecule CH4. It's a tetrahedron. This is honeycomb. It's produced by bees. The basic shape is a hexagonal prism. This is snow that's fallen onto a table. It forms a truncated cone. There are two kinds of polygons, regular polygons and irregular polygons. In regular polygons, there are equal sides and equal interior angles. Irregular polygons have unequal sides and unequal interior angles. This is an equilateral triangle. The angle is 60 degrees. The sides are all the same length. This is a square. Each angle is 90 degrees. This is a pentagon. Each angle is 108 degrees. This is a hexagon. Each angle is 120 degrees. These are examples of irregular polygons. Notice how all the lengths are different and the angles are different. These are two different kinds of solids. The one you're most likely to deal with in this course is a right solid. The other kind is an oblique solid. Can you see the difference between them? In a right solid, the lateral edges are perpendicular to the base, as shown in the diagram. In contrast, the oblique solid, the lateral edges are not perpendicular to the base. As you can see, this angle here is more than 90 degrees. The height is measured from the top, perpendicular to the base. That is the height of that solid. Polyhedrons are a special kind of solid. A polyhedron is a solid that is bounded by polygons called faces that includes a single region of space. An edge of a polyhedron is a line segment formed by the intersection of two faces. The vertex of a polyhedron is a point where three or more edges meet. The plural of polyhedron is polyhedra or polyhedrons. If you look at this diagram, the corners are called vertices. The top is a face. Every side of the object is a face. The edges is shown in red here. So you should be familiar with those parts of the polyhedron. The 5 Platonic solids. They're a special kind of polyhedron. Their faces are made of regular polygons. They were named after the Greek philosopher Plato, as shown in this picture. The first one is a tetrahedron. It has 4 faces. Each face is an equilateral triangle. Plato said that this solid represented fire. This solid is a cube. It has 6 faces. It represents the Earth. This is an octahedron. It has 8 faces and represents the air. This is a dodecahedron. It has 12 faces and represents the universe. This is an icosahedron. It has 20 faces and represents water. The non-polyhedra. These solids have curved faces and no straight edges. Do you know what they are? Think about it. The first one is a cone. Note how the faces are curved. You cannot have curved faces in a polyhedron. The cylinder is also a non-polyhedron because it has a curved face here. Spheres are completely curved all over the surface, so they are not polyhedrons. Let's look at the parts of solids. This is a square-based pyramid. The base is the bottom part of the figure underneath. The base edge are the edges around the base. The vertex are the corners of the solid. So this solid has 4 vertices around the base, 4 around the base and 1 at the top. The top vertex is called the apex. The lateral face are the faces of the pyramid. There are 4 faces here and each face is a triangle. The lateral edges are the edges of the lateral face and it has 4 of them. The slant height is the length down here, which is the height of that triangle. This is the height of the actual pyramid from the apex to the base. The nets of solids. Nets are 2-dimensional representations of their respective 3-dimensional solids. The nets of many solids helps us visualize them and to calculate their surface area. This is the example of a 3D hexagonal prism. We open up the prism as such and we can see the 2D net. We'll look at nets now. This is a net of a prism. It's a cuboid. Let's open it. It opens up and we find that we have 4 rectangles, quite long ones, and the base is a square and the top is a square. This is a net of a pentagonal prism. So it opens up to reveal 2 pentagons, which gives it the name, and 5 rectangles around the outside. This is a net of a cylinder. We open up the cylinder to reveal 2 circles, and the central part, which is the height by 2 pi r, because this length of this rectangle is the same as the circumference of the circle. So this length is 2 pi r. This is a net of a triangular base pyramid. We can see that there are 3 large triangles around the outside. They're the lateral faces. And there's 1 smaller triangle, which is the base in the middle. This is the net of a square-based pyramid. Again, we have 4 triangles on the outside that are the lateral faces, and the central part is a square. The net of a cone. We open the cone up, we see we have the base, which is a circle. This is the lateral part of the cone, which is called a sector, and we'll learn more about that in the coming lessons. This is the net of an octahedron. It's a Platonic solid made with 8 equilateral sides. That's one kind of net, but for octahedrons, there are actually many kinds of nets, as you will find out. This is the net of a dodecahedron. It has 12 regular pentagon sides. Okay. So for your exercises, I recommend you check your book or the internet for examples of how to draw the nets of these solids. And there's more than one way to do that as well. In these cases, you just give the name of each solid. Okay, so I hope that will be okay for you, and I hope to get that work from you soon. Thank you. And I'll send a new video quite soon. Bye bye.